Hello and welcome to Data Structures and Algorithms in Python. This is an online certification course being offered by Jovian. Today we are looking at Assignment 1, Binary Search Practice. So let's get started. First thing we'll do is go to the course website, pythondsa.com. On the course website, you can enroll for the course and view all the previous lectures and assignments. For assignment 1, you may want to review the video and notebook for lesson 1. Let's open up assignment 1. It's called Binary Search Practice. Now in this assignment, you will apply and practice the concepts that we covered in the first lesson. So you will understand and solve a problem systematically, implement linear search and analyze it, and optimize the solution using binary search and ask questions and help others on the forum. Let's open up the starter notebook for the assignment, which contains the problem statement and other information. Now this is a notebook you're looking at hosted on Jovian. You can see some description here, and if you scroll down below, you can also see some code. And you will need to execute this notebook, modify the code within it, and record a new version which you can then submit to see your score. So let's start reading through it. Now as you go through the notebook, you will find 3 question marks in certain places. To complete the assignment, you have to replace the question marks with appropriate values, expressions, or statements to ensure that the notebook runs properly end to end. Now keep in mind that you need to run all the cells, otherwise you may get errors like name error or undefined variables. You should not be changing any variable names or deleting any cells or disturb any existing code. You can add new code cells or new statements, but do not redefine or do not change some of the existing variables. You will be using a temporary online service for code execution, and we'll see how to use it in a moment. So keep saving your work by running jovian.commit at regular intervals. And then the question marks optional will not be considered for evaluation. Although we recommend doing them, they are for your learning, but you can make a submission before you have solved the optional questions. Now you can make a submission back on the assignment notebook page, and we'll see how to do that. And if you're stuck, you can ask for help on the community forum. It's listed here. And we'll see how to do that as well. Now, one final thing I want to mention is you can get help with errors or ask for hints. You can even share your code and errors that you are getting in the code, but please don't ask or share the full working answer code on the forum. This is so that everybody has the opportunity to work through the problem statement on their own, make mistakes, learn from their own mistakes, and arrive at the right solution. Now, how do you run this code? The recommended way to run this code is by clicking the run button at the top of the page and selecting run on Binder. But you can also run it using some other options like Google Colab or Kaggle, or you can run it on your computer locally. So we're going to use the recommended method, run on Binder. And this may take a minute for you to start. You can see that the server is launching already. And here we go. Now we have the notebook running in front of us. The first thing I like to do is go to kernel and click restart and clear output so that we can see all the outputs of the notebook from scratch. And I'm also going to toggle the header and the toolbar so that we can zoom in a bit. So now the same Jupyter notebook is now running online on a platform called Binder. And before starting the assignment, let's save a snapshot of the assignment to our Jovian profile so that we can access it later and continue our work. So I'm going to run pip install Jovian. This is going to install the Jovian library. Then run import Jovian to import the library and set a project name. Here I'm just calling it binary search assignment, and run jovian.commit. Now you have taken a starter notebook which was hosted on my profile, and then you've run it on Binder. As soon as you run jovian.commit, a copy of the starter notebook gets saved to your profile. So what you will see here is a link to a notebook hosted on your Jovian profile. Let's open it up here and see. So now this is your personal copy of the assignment notebook. Any changes that you make here and run jovian.commit will get added to your profile. So if you want to come back and continue your work, then you do not have to go back to the original starter notebook, which contains all blanks. Rather, you can come back to your profile, and you can come to your profile simply by opening jovian.ai. And on your profile, you can go to the notebooks tab. And on the notebooks tab, you will be able to find, as you can see here, you will be able to find the binary search assignment here. There you go. This is the binary search assignment that we just created. And you can open it and run it on Binder to continue your work. So moving along, this is the problem we are looking at here. You are given a list of numbers obtained by rotating a sorted list an unknown number of times. Okay. So we have two new terms here, rotating a sorted list. And don't worry if you don't know what that means. Normally, if you see any new terms in a problem, they will be explained somewhere within the problem itself. For instance, here you can see that there's a definition. We define rotating a list as removing the last element of the list and adding it before the first element. For instance, rotating the list 3241. Leads to removal of the last number and then placing it at the very beginning. So you end up with the list 1324. This is a new operation that we are defining. This is not something standard, but you will find that a lot of problems will define new terms or new operations so that it becomes easier for you to understand the problem. So that's rotating a list. Now rotating a list once produces 1324. Now if you rotate that list again, the resulting list one more time, then you will end up with 4132 and so on. And then the other term is sorted. So sorted refers to a list where the elements are arranged in increasing order. In this case, we have numbers, and the numbers 1, 3, 5, 7 are arranged in increasing order. So this is a sorted list. But if this was 3, 2, 4, 1, well, the numbers are not arranged in increasing order. So that's not a sorted list. So you are given a list of numbers obtained by rotating a sorted list an unknown number of times. For instance, this sorted list 0, 2, 3, 4, 5, 6, 9 is rotated a certain number of times, and you can verify that if you rotate this 3 times, you end up with the list 5, 6, 9, 0, 2, 3, 4. Right? You can see that first 9 comes to the beginning, then 6 comes to the beginning, and then 5 comes to the beginning. So you need to write a function. And you're given just this, the list. You're not given the original sorted list. You're given the list obtained by rotating some sorted list an unknown number of times. Now you need to write a function to determine the minimum number of times the original sorted list was rotated to obtain the given list. Your function should have the worst case complexity of order log n, where n is the length of the list. And you can assume that all the numbers in the list are unique. Okay. So 3 parts. Write a function to determine the minimum number of times you need to rotate the original sorted list. In this case, it is 3. The function should have the worst case complexity of log n. So this determines correctness, and this determines efficiency. And then this is some additional information to help you that you can assume all the numbers in the list are unique. If this was not mentioned, you would also have to handle the case where your list does not contain unique numbers. Now, we will apply the method that we have been applying all throughout this course for solving the problems. Number 1, state the problem clearly, identify the input and output formats. Number 2, come up with some example inputs and outputs and try to cover all the edge cases. Number 3, come up with a correct solution for the problem and state it in plain English. Number 4, implement the solution and test it using some example inputs, and having test cases and then implementing a solution allows you to test them using the example inputs and fix any bugs. That's why it's very important to have some test cases. Number 5, analyze the algorithm's complexity and identify any inefficiencies. And number 6, apply the right technique to overcome the inefficiency. And then you go back and repeat steps 3 to 6. Come up with a correct solution, implement the solution and test it, and analyze the algorithm's complexity. And you can review lesson 1 for a detailed explanation of this method. Now let's apply it step by step. The first step is to state the problem clearly and identify the input and output formats. Now, while it is stated clearly enough, it always helps to express it in your own words in the way that it makes it most clear for you. And this is something that you can keep returning to rather than the original problem statement, because this is something that you will understand better. And it's okay if your problem overlaps with the original problem statement, but do try to express it in your own words. So in this case, what I've just done is I have double clicked here. So once you double click, you can now edit this text cell, and now we can start writing a problem. So let's say given a rotated list, we need to find the number of times it was rotated. And okay, I think what I've probably missed here is that it is a sorted list. So given a sorted list that was rotated some unknown number of times, we need to find the number of times it was rotated, right? Maybe I'm just going to say given a rotated sorted list, because technically the input is not a sorted list, it's a rotated sorted list. So given a rotated sorted list that was rotated an unknown number of times, we need to find the number of times it was rotated. Now doing this exercise helps you determine if you've understood the problem correctly. And you may often find that, okay, there's a certain detail in the problem that you missed. Okay, but at this point, I'm happy with my description. And you will see that it is matching the description to a large extent. But it's something that I understand better. So I'll just refer to this from this point. Now I'm assuming here that I know what rotation and sorted means. Otherwise, I could also include those. Then here's a question. The function you will write will take one input called nums. What does it represent? And give an example. Okay. So once again, we double click on this, and one input is nums. So this is a sorted rotated list. And let's give an example here. Let's say we take the sorted list 3, 5, 6, 7, 9, and then we rotate it a few times. Let's say we rotate it a couple of times. So we end up with this sorted rotated list. So that's our input. So we've answered the question here. Now the first question was to express the problem in your own words. This is the solution. The second question was, what does the input nums represent? Give an example. It represents a sorted rotated list, 7, 9, 3, 5, 6. The third question is, the function you will write will return a single output called rotations. What does that represent? Well, you have to write a function that identifies how many times the list was rotated. So this is the number of times the sorted list was rotated. Okay. And in this case, the example that we have is that this sorted list was rotated twice. 3, 5, 6, 7, 9 was rotated 2 times. So you mentioned 2 here. Now you can see these back quotes that I'm using here. This is next to the number 1 on your keyboard or below the escape key. What these back quotes let you do is they let you express text as code within Markdown. You can see that they have a gray background and they have a different font. This looks a lot more like code. Same is here true for nums. So you can use Markdown and its features to your advantage to organize your descriptions and your text better. Okay, so now based on the above, we can now create a signature of our functions. We have a function called counts rotations. It takes a list of numbers and it returns. Well, right now we're just putting pass in here, but we know that it's going to return a single number rotations. Now, after each step, remember to save your notebook. So we are going to just run jovian.commit. And now if you leave your computer, you to not have to be worried that your work may be lost. So you can go in here and you can open up this notebook from your Jovian profile and press run at any point to run this notebook. Now step 2 is to come up with some example inputs and outputs and try to cover all the edge cases. And our function should be able to handle any set of valid inputs. So here is some variations that you can encounter. A list of size 10 rotated 3 times, a list of size 8 rotated 5 times. So these are 2 generic examples. And then a list that wasn't rotated at all, a list that was rotated just once, a list that was rotated n-1 times, where n is the size of the list, a list that was rotated n times. And what do you mean by rotating the list n times? Well, let's see. An empty list and a list containing just one element. And if you can think of more test cases, you should definitely add more test cases here. And what we'll do is we will express our test cases as dictionaries. So this will help us organize the test cases and test them all at once more easily using helper functions. So you can see here that we've organized one test case here and we've expressed the test case as a dictionary. So here we have the input to the test case, that is the input key, and then we have the output to the test case. Now, because a function can take many arguments, the input itself is going to be a dictionary, and then for each argument, in this case there's just one, so we just call it nums. We have the input here, and this is the size of the output. Okay, so let's create this test case, and let us then, if you want to fetch the actual input and output out of it, so here we can fetch test input nums. That's going to give us the nums. We can use test input. The output should be test outputs. This seems to be an error. And the result is count rotations num0. Okay, so this is the actual result obtained by passing the test case into count rotations. And you can see that the result we get back is none, because right now we do not have any code. It just says pass inside. And the result and the output are not equal, because the output is the number 3, but the result is none. So that's okay. Our test case is failing right now because we have not yet implemented the function. But as soon as we implement it, we expect to see the test case passing. Now, to help you avoid all of this work, we have given you a function called evaluate test case. So from jovian.python DSA, you can just import evaluate test case and then call evaluate test case with the function you want to test and the actual test case. And you can see here it prints the input that was passed in, the expected output, the actual output that was obtained, and the test result. In this case, the test result was failed. And the execution time is also printed here if you just want to evaluate if a certain implementation is faster than another. So now your job is to create test cases for each of the scenarios listed above. So here is test 0, that is same as the original test case that we had created. Now here is test 1, a list of size 8 rotated 5 times. I will let you create this, but it will look something like this. You will open up, you'll replace the 3 question marks with, let's say, a list of size 8. So 1, 2, 3, 4, 5, 6, 7, 8. And you can imagine that if this was rotated 5 times, then 1, 2, 3, 4, 5. 5 of these numbers will then move to the first position. And you get this as the input numbers. And the output, well, it was rotated 5 times. So I think you can guess that the output here should be 5. Now here is a list that wasn't rotated at all. What should be the output here? I'm sure you can guess that the output here should be 0. So I'll let you fill this out. Here is a list that was rotated just once. So let's fill out this one. So this list rotated once would give us 7, 3, 5. There you go. A list that was rotated n-1 times, where n is the size of the list. Okay, I'll let you do that. a list that was rotated n times where n is the size of the list. Okay, what does that look like? So you take this list and then you first put 10 in the first position, and then you put 9 in the first position. So 9, 10 comes to the beginning, and 3, 5, 7, 8 comes after it. Then you move 8 to the first position, then you move 7, then you move 5, then you move 3. If you move all of these back to the first position, you end up with the same list. So you've rotated it n times. Now, what should be the output in this case? There are about 6 numbers here. So is the output 6? I don't know, I'm not so sure, because remember the question, the original question says, write a function to determine the minimum number of times the original sorted list was rotated to obtain the given list. So it has to be the minimum number of times. So we may want to just go back and change this. We need to find not the number of times it was rotated, but the minimum number of times it was rotated, or it needs to be rotated, right? So coming back here, the output should be not 6, but 0. So keep that in mind. Then here's an empty list. I'll let you figure out what should be the nums and the output here. And here is a list containing just one element. Once again, should be pretty straightforward. Can you rotate a list with one element? I'll let you decide. And then we are taking all the tests and putting them into a single list. Now, since I have not defined all the tests, I am not going to use this definition which contains all the tests, but I'm just going to pick the number of tests that I have defined. So we have defined here test 0, test 1, test 3, test 5. I'm just going to put in test 0, test 1, test 3, and test 5. And that's the full set of tests that we have. Now you definitely need to fill out all the test cases, and if you can think of some other cases that you should be testing, then you should include those test cases here as well. Okay. Now to evaluate your function against all the test cases together, you can use the evaluate test cases helper function from Jovian. So there are two functions. Evaluate test case works with a single test case, and evaluate test cases works with a list of test cases. So we have a list of test cases here. I have 4, but you should have about 8 at least, and a few more if you've created them. So we can import from jovian.python DSA evaluate test cases, and then invoke evaluate test cases with the count rotations function. Still, we don't have any logic in the function, so all the test cases should pass, and the list of test cases we've created. So you can see test cases 0 fails, 1 fails, 2 fails, 3 fails. So out of the 4 test cases, none of them have passed. No problem. We have completed step 2, which is to create some test cases, and we'll know once we've defined a function whether the function definition is correct. Now the next step is to come up with a correct solution for the problem and state it in plain English. And there's a hint here for you already. Coming up with the correct solution is quite easy, and it's based on this simple insight. If a list of sorted numbers is rotated k times, so you keep rotating it step by step, moving the last number to the first position, then the smallest number in the list ends up at position k. Okay, and you can verify this. It's very simple to do this. Whenever you have a doubt, just create a new cell. By the way, you can create a new cell by clicking on the left side of a cell and clicking insert cell below. Or if you're in a code cell, just click here near the prompt and press the B character. And that adds a new cell below. So let's take the list 1, 3, 5, 7, 5, 6, 7. And let's rotate it k times. Let's try with k equals 2. So if you set k equal to 2, then you're going to take 2 of these numbers from the very end and move them to the beginning. So that means 0 comes at position, 6 comes at position 0, 7 comes at position 1, and the starting element in the sorted list now comes at position 2. That's interesting. Let's move the third element as well. Okay, so now we've moved 3 elements or rotated the list 3 times, and the smallest element ends up at position 3. So it seems to hold true, and you can verify this now with a larger list, smaller list, empty list, and all the test cases that you have. And if a list was sorted k times, a sorted list was rotated k times, then the smallest number in the list ends up at position k, counting from 0. Further, it is the only number in the list which is smaller than the number before it. And you can see this once again. The smallest number is at position 3, and all of these numbers are higher than the numbers that come before them, except the number 1, which is smaller than 7. So we simply need to check for each number in the list whether it is smaller than the number that comes before it. If there is a number before it, then our answer is simply, which is the number of rotations, is simply the position of this number, right? So if you can find the position of the number which is smaller than the number that comes before it, the position of the number is also equal to the number of times the sorted list was rotated. And if we cannot find such a number, then the list wasn't rotated at all. And that's it. You can see here in this list, now applying this logic, 3 is the number, the smallest number. And not only that, 3 is the only number which is lower than the number that precedes it, the predecessor, which is 29. And since 3 occurs at position 4, well, actually 3 occurs at position 3, 0, 1, 2, 3. The list was rotated exactly 3 times. Now we can use the linear search algorithm as a first attempt to solve this problem. And the linear search simply involves walking through this list from the left to the right. So now the task for you is to describe the linear search solution in your own words. And please write it in your own words, but here's how I'm going to write it. Let's say create a variable position with value 0. So this is the position for tracking. This is for tracking the position. Then look at the number at the given position, and not only look at it, but compare the number at the, let's say, the current position to the number before it. Now, if you're starting position with the value 0, maybe we may not, there's no number before it, so we may not be able to compare it with something. We may even just start with the value 1. That's all right. If the number is smaller than its predecessor, then return position, because position is the answer. We found a number that is smaller than its predecessor. There's only one such number. Otherwise, increment position and repeat till we exhaust all the numbers. Okay, simple. Now you can add more steps if your description of the algorithm requires more steps. That's perfectly all right. But at this point, we have a very clear description of the solution. Now we're starting with the position 1, not 0, because we also want to track the previous position. Now we import Jovian here and commit our project once again, and keep saving your work after every step so that you can continue your work. So now we're talking about implementing the solution and testing it. So let's implement the solution. We said that we want to start with position. We want to start with position 1. And when should the loop be terminated? Well, while position is less than the len of nums. I guess that's fair. And then what is the success criteria? So we have if position greater than 0 and nums of position is less than nums of position minus 1. Okay, so that's the success criteria here. Now you can see that there's a condition if position greater than 0 here, so we don't really need to start position at 0. We can start position at we don't really need to start position at 1. We can start position at 0 as well, and all that will happen is this condition will get skipped and position will get incremented. And this is a good practice because whenever you iterate over a list, you normally just want to start with 0 just to avoid any confusion later when you're reading the code, that did you intend to write 0 here or 1, etc, etc. So just put in position equals 0 here and simply skip the check here. Simply skip this comparison if position is not valid, right? So whenever you're accessing an element from inside a list or inside a dictionary, you always want to make sure that that index or that key is valid. Okay, here we are making sure that the key position minus 1 is valid by checking position greater than 0. In any case, we now have the logic, and finally we are saying that if the number at position is less than the number that comes before it, then we return that. And that's just going to, if it's not, then it's going to increment the position and it's going to check again and again and again till we run out of numbers. Now, if you've exhausted the entire list, then it follows that there were no rotations or there were n rotations exactly. In either case, the number we return should be 0. Okay. So keep this in mind. You may have the doubt, should you be returning minus 1 here or should you be returning 0 here? Well, the question does specify clearly that you are given a sorted rotated list and you have to find the number of times it was rotated. Now, obviously minus 1 rotations are not possible. So minus 1 would not be a valid return value from your function. And this is the reason we write test cases too. Now let's evaluate the test case. So let's call evaluate test case for a single test case on count rotations linear, and let's see what the test case is. This is the test case here and this is the output. We call evaluate test case with count rotations linear and test, and that gives us a linear search result. And you can see here this was the number, the list of numbers, this was the expected output, and this was the actual output. So great, our function seems to have passed the test case. Now we can evaluate all the test cases by calling count rotations linear on all the test cases together, and that gives us a whole list of test results. Test case 0 and 1 and 2 and 3, all of them have passed. Now if you had put in minus 1 here, you would see that one of the test cases would fail, which is the case where the list wasn't rotated at all or was rotated n times. Okay. So that should tell you that the answer here should be 0. So that's our linear search algorithm. And at this point, you may face issues. You may feel stuck. You may not be able to figure out how to write the code. And that's perfectly all right. That's part of learning. You may face errors. You may face exceptions. For instance, if you did not have this check here, position greater than 0, or maybe what you had here was some other condition, like position less than equals position plus 1, and that's okay. Then you can go to the forum and post your issue. So let's open up the forum here. This is the forum discussion for assignment 1, and you can go into the original topic here, which is a longer discussion. So this is where everybody's posting small issues. So you can see that there's about 321 messages that have been posted. You can start looking through this forum. You can start reading through some of the posts. You can even search. If you press Ctrl F, and you can even search for questions here. Now, if you want to post your own question, scroll down to the very end, or you can just click this button here and click reply. Okay, and mention your question here. I have an issue should I return -1 or 0 in the case the list has not been rotated? Okay, maybe that's, and if you want, if you have code that's not working or there's an error, you can also include a screenshot of your code, or I'll show you another trick. You can actually include, let's say you commit your notebook. So let me come up here. I've committed my notebook. And if you have a particular line of code that you want to share, you can actually click copy cell link and paste it here. So that will give a link to the entire cell. And if somebody clicks on the link, then they can view that specific cell of the notebook directly. Let's see. You can see here that it brings us directly to this specific cell. There's another option. You can even click on embed cell. Okay, for secret notebooks, we do not allow embedding, but copying the cell link should work. And then click reply, and your question will be posted and somebody will reply to your question. Just come back to the forum in a few hours or maybe the next day and you should see an answer. You will also receive an email. So that's the discussion topic. You can also go back to the topic here, the category here, and create a new question. You can see that if you want to start your own thread, if you think your question deserves a deeper discussion where multiple people can reply, you can also create a new thread by clicking new topic. Okay, so keep this in mind and do make use of the forum. What we've seen is people who are active on the forum are at least 4 to 5 times more likely to complete the course and earn the certificate of accomplishment and continue working on these topics after the course as well. Okay, so the next step is to analyze the algorithm's complexity. And the way to do this, if you've seen lesson 1, is to simply count the number of iterations, the number of executions of the while loop. Now, if you have a list of numbers of size n, then you can see here that this is the key loop here, while position less than the length of numbers. So then there will be n loops or n iterations, and then inside each iteration we're performing certain comparisons and returning things. So all of these are in effect constant time, and based on this you can probably tell that the complexity of linear search is order of n. So you can just put in a big O n. In the big O notation, this would be order n. So that's the first part of the assignment, linear search. Now the next step is to apply the right technique to overcome the inefficiency, and that's where you can now read through the rest of the assignment. Now the idea here is this. Binary search is the technique we'll apply, and the key question we need to answer in binary search is, given the middle element, can you decide if it is the answer, which means if it is, let's say, the smallest number in the list, or whether the answer lies to the left or the right of it. Okay, so if the middle element is smaller than its predecessor, then it is the answer. We already know that because there's only one number in the list that is smaller than its predecessor. So you can see here, for example, now if the middle element was 1, which it's not, but suppose the middle element was 1, and you can see that 1 is smaller than 8, then we know that 1 is the answer. So the position of the middle element is the answer. However, if it isn't, then we need a way to determine whether the answer lies to the left of the middle element or to the right of it. And consider these examples. So here you can see that the middle element is 3, and the answer is the position 2. So in this case, the answer or the smallest element lies to the left. On the other hand, in this case, you can see the middle element is 4, and the smallest element -1 lies to the right of it. So now you need to apply your mind and think of a check that will help you determine if the middle element, given the middle element, if the answer lies to the left or the right of it, right? And we're looking for the smallest element, remember. So the logic here, if you just spend a couple of minutes, you will come up with this quite easily. If the middle element of the list is smaller than the last element of the list, okay, or the last element of the range that we're currently looking at, that means that all the numbers here are in increasing order. So then the answer lies to the left of it. On the other hand, if the middle element of the list is larger than the last element of the range, that means that because we know that the list is a rotated sorted list, so that means that the numbers increase up to a point and then there's a decrease and then they continue increasing. That's the only way in which the final element can be smaller. So that means the answer lies to the right of it. So that's the logic here for binary search. And now what you have to do is describe the binary search solution in your own words. So here once again you have these 4 or 5 lines. And it's very important that you do this, because if you cannot express it, then coding it is also going to be difficult for you. So always do this exercise of expressing the solution in your own words when you're practicing, when you're solving a coding challenge or something. Even in an interview, it's also very important, because the first thing you need to do is to communicate to the interviewer your thought process and how you're thinking about the problem. So the first thing you need to do is describe a simple solution in simple words, and then they may or may not ask you to code that solution. And then the next thing is to identify the complexity or identify the inefficiency. Then the next step for you is to describe the optimal solution or the binary search solution in your own words. Okay. Now, if you don't describe the solution in your own words and you start writing the code, they may not be able to follow your code. So even if you've written mostly correct code, maybe with 1 or 2 edge cases wrong, they may still have a feeling that you don't know what you're writing. But if you explain the solution clearly to them, they will know that now you understand the solution, and they will be able to follow the code as you write it, and they will be able to pick up mistakes or errors and help you with the errors. One secret is that interviews are always open to helping you unless you make them really confused. So keep that in mind and describe the solution in your words. Once you do that, you can commit. Now the next step is to implement the solution. Now you implement the binary search solution as described in the previous step. Let's run this again. Yeah. So you run count rotations, define the function count rotations binary. Now you may want to review lesson 1 here on how to start it out. You'll see that low starts out at 0 and high starts out at len nums -1. And I will not solve the rest of this, but there is a certain condition here between low and high. So in binary search, we are starting with the entire list as the range. Then we're looking at the mid number. So we're getting the mid position, and we look at the number at the mid position. Then we check if the middle position is the answer. So if the middle position is the answer, we return the middle position. Then we check if the answer lies in the left half. So here's a condition where you decide if the answer lies in the left half. And if the condition holds true, all we do is we change the high, so we change the end point of the range to mid -1. And then we check if the answer lies in the right half. In that case, we change the starting point of the range to mid +1, and the while loop repeats. Okay, so that's the general logic of binary search. And one thing you have to keep in mind is if none of the elements satisfy the criteria that you have, what is the answer? And this is a very important condition. This is where it is very easy to go wrong. This is also called the edge case or the trivial case. So you should handle and think about this carefully. Okay. And then once you've done that, you can evaluate the test case, and you can a single test case, you can evaluate multiple test cases. Now, if your test cases are failing, you may want to enable this print statement inside by uncommenting it, but make sure to comment it out at the end once again. And the print statement will help you see what the low, high, and mid points were. Now you may want to then take up pen and paper, look at an example that is failing, and see if the printed numbers match what you expect to see. Debugging your function is a very important skill, so keep that in mind. and use a debugging technique like this by adding print statements and working out the same problem side by side on paper to fix your issues. Otherwise, you may feel lost if you're not able to look into the internal workings of the function. Next, you have to analyze the algorithm's complexity and identify inefficiencies. This should be straightforward enough. We've already looked at the complexity of binary search, but all you need to do is make sure that what you're doing within the algorithm matches the analysis that we've done earlier. So the problem size reduces by half each time, and then we are doing constant work in each step before solving a problem of half the size. So that should roughly give you an answer. And keep committing your work. Now finally, to make a submission, you have two options. Now one option is to take this link. So your notebook has been committed here. And you can come to the assignment page. Let's open up the assignment page, binary search practice. Come down here and paste this link here and click submit. Now once you click submit, the assignment will be submitted and it will go into automated evaluation. So in about a couple of minutes, maybe up to an hour, depending on the queue of submissions from different participants, you will receive a grade over email. Let's just refresh the page. And it seems like there was an issue here. The issue was that count rotations binary was not defined. So it's possible that this happened. Count rotations binary did not get defined because there are a bunch of question marks here. So we may need to then fix the issue and then come back and make a submission once again. Okay. So here is a fail. I have received fail grade. I will go back and I will fix the issue and then come back. Okay. Now it's very important for you. That's why to have good set of test cases for you to test your function. So that when you submit it or when you get an error, you can maybe look at your function's performance on the test cases and fix anything that needs to be fixed and add new test cases if you need to. Now, one other way you can submit is by simply running the code by jovian.submit assignment equals python dsa -assignment1. The code is mentioned here. You can see here that the submission was made and you can verify your submission on this page. Once again, I received the same fail grade. Okay, so that's that. That's assignment 1. So what should you do next? Review the lecture video if you need to and execute the Jupyter Notebook. You may want to keep the Jupyter Notebook running side by side as you're working on the assignment. Then complete the assignment and even attempt the optional questions. Now, if you scroll down here on the assignment notebook, you will find that there are some optional questions for you. Here's one bonus question. Use the generic binary search algorithm. So inside the Python DSA module in Jovian, there is a function called binary search. You can use the generic binary search example. Then here's an optional bonus question 2. Handle repeating numbers. We did say that you can assume that there are no repeating numbers in the list, but here's one list with repeating numbers. Can you modify your solution to handle this special case? And then here's an optional bonus question 3 about searching in a rotated list. So you're given a rotated list. Now, instead of finding the number of times it was rotated, you're trying to find the position of a certain number, for instance, the position of 6. Can you apply binary search and modify your previous solution slightly to search within the rotated list and find the position of a given number? Okay. Now, here's a hint. You can simply identify 2 sorted subarrays within the given array and perform a binary search on each subarray. To identify the 2 sorted subarrays, you can use the count rotations binary function. So that's one potential solution. Another way is to modify the count rotations binary function to solve the problem directly. So it's a very interesting problem to solve. And if you found the assignment easy, then you should definitely solve these bonus questions. And if you can solve this question by yourself without taking additional help, then you can solve pretty much any problem related to binary search that may be asked in an interview, because most of the questions are some variations of something like this, and this is pretty much the hardest problem you may get asked. You can also test your solution by making a submission on LeetCode, and this is only for the final optional question. And there's a thread on the forum where you can discuss the bonus questions separately as well. So do make use of the forum thread too. Here it is, optional bonus questions discussion. So do participate in the forum questions, forum discussions, and join or start a study group if you haven't already. If you found that you've fallen behind over the last few weeks after starting this course, a great way would be to get 2, 3, or 4 of your friends, ask them to join the course as well, have a weekly discussion with them, set aside 1 hour a week where you can all watch the videos, attempt the assignment, and then have discussions and help each other out. That's a great way to learn. So that was assignment 1 of data structures and algorithms. This is called binary search practice.